Hey everyone, welcome back to my channel. This is Elaine Giselle, and if you're new to the channel, I make videos about education, electronics, and lifestyle, and whatever it is that I can think of that may add value to your life. So in this video series that I'm making, I will be making a tutorial on Proteus simulator. So I already made an Arduino circuit simulator, Arduino circuit simulation in Proteus. In my previous video, you can check it out somewhere here. I'm going to put it here and on the description below. And I'm going to start by introducing how to navigate, explore Proteus simulator, and make a very simple circuit. Second video, I will be making a half-wave rectifier. Lastly, I'm going to make a full-wave rectifier. So if you're interested, continue watching this video. I'm also going to link the playlist somewhere. So let's go. Okay, again, we're going to be making a full wave rectifier. So we need a voltage source, an AC voltage source, a bridge network, because we're going to be using a bridge network for our full wave rectifier. And then we're going to be using a resistor and an oscilloscope to measure the input and the output. So let's go ahead and check or make our circuit. So let's click schematic capture. All right. And let's click P to access the components. And we're going to need the V sign. This is our AC voltage source. So just double click it to add to the devices list. Search for bridge. Right. This is the bridge network. So click diode and then the bridge rectifier or the generic one if we want to use this generic one. Right. So double click. And then add the resistor. And then the generic. So we're just going to use the generic devices for this one. All right, so the three components are already here. So we can start making our bridge network. Right, zoom it a little bit. And then we can add the V sign somewhere here. The bridge network and our resistor. Okay, so let's rotate this. You can zoom it in using your mouse scroll and then adjust the view. All right, if you're familiar with a full wave rectifier, this upper terminal for these first two diodes, the upper diodes, should be connected in the positive or no, in the upper terminal of your V sign. And then this one should be connected to the node between your bottom diodes, right? And then this one should be connected to your resistor because this is where we measure the output voltage, right? Okay. So this is the connection of our bridge rectifier. So let's change our V sign. Again, if you check our half-wave rectifier circuit somewhere here, you can see that I've changed the default values for the amplitude and the frequency. So let's change this to 12 just for the sake of simulation, and let's change to 60. Click OK. All right, and then we can change this value to 1K if you like. Okay, I'm just gonna move this here. Then, oops, okay, that will be fine. All right, now next step is we need to use our oscilloscope to measure the output, the input and output waveform. So we can access the oscilloscope from the instruments. And then from here, we can add it. All right. So the same with the half-wave rectifier, we're going to use two channels in the oscilloscope. One is for the input. The second one is for the output. So for channel A, we're going to use it as an input. Okay, we're just going to connect it to our V sign terminal. And then channel B should be on the output, and that is across your resistor. Okay, so we already connected the input and output channels to check for the waveform. So we can now run the simulation, and we can expect that the output is a full wave. Run. All right. So you can see here, the yellow one is the input and the blue one is the output. So for channel C and D, again, we're not using it. So let's just turn it off. All right, and then we can adjust this horizontal knob to have a better view of the wave. Okay, so this is now our input and output waveform. So the blue one again is the output. So we can adjust the position of our input. Right, and we can zoom that a little bit. All right, so this is our input and output. Okay, so as you can see, we have a full wave. We have a pulsating DC. So what it does, this bridge rectifier converts the AC to a pulsating DC. So I hope you learned something from this video, and I hope you have a successful simulation of your full wave rectifier. So that's it for now, and I'm going to see you on my next video. So don't forget to like, share, and subscribe, and click the notification bell. So see you on my next video. Bye.